Blood?
All right, so this is what you should have had. This is called a contingency table. It just lays out the totals so that you can see them all in one place. Now, the way to visualize this is using what they call a stacked bar graph. And I haven't asked whether you need to do this. I started looking at code that I have where I've done this before. But I'm going to take one from your book so you can see what it looks like. So this is what it looks like. They call it stacked bar graphs. This whole bar represents 100% of the people that were planted at Yahtzee, and this percent of those individuals were the ones that ended up yawning themselves, and this percentage didn't. So you can actually see a stacked up side-by-side comparison of the two groups. And what do you think looking at this?
Not so different. It's overall, it's statistically significant.
Yeah, we have to actually punch the numbers for that, but it's not something you call your mom home about. It's like, guess what I did? And you got to see the stacked bar graph that I got today in class. Not going to happen?
Probably not.
I think you should, just because I said that tonight you say, yeah, I had
She'd
to.
probably be like, that's great, honey, I'm so proud of you. Get you on my life.
And then she'd get off the phone and say,
She'd be like,
she's really not getting the right thing. All right, so let's do some numbers. I mean, that was just a look, and it doesn't look stunning. We can think about why in a minute, but let's calculate these percentages. So the proportion of individuals that got the Yahtzee versus proportion that didn't. Take boards and put them up there. What? Someone can give you that. You can write out a fraction.
The bougie piece.
Oh, I had one of those
Chardonnay.
Oh, did you find your strip?
I didn't find it.
White wine.
I left it like right there. I remember I said the
No. I have an extra one at home if you want it.
has an extra set if I didn't find it.
Okay, let me know. No, it's one why don't you go ahead so we actually have the numbers up.
Yeah.
I want to make sure before I took my phone.
You were on that.
You don't fuck with her.
And then I had like
All right, go ahead. Does everybody understand?
Or you'll click.
Take seats. So they're just fractions.
Man, wouldn't Yahtzee had CP 34 divided by 20? No, it's a percentage that yawned with the C.
Yeah.
With it.
So think of those two stacked bar graphs that you had. One was no seed and one was seed. You didn't know what to do?
Oh no, it's right there.
No, but I saw you do it after I showed the answer.
No, you didn't.
Yeah, I did. I know what I saw.
I did it for you.
You know, like what I tell my daughter, if my scrutiny's on you, it means I love you more. And the BTO's ways because he loves you. Yes. Yes. This will be recorded. All right, so what we work with is the difference of these two. We take the difference of these two statistics and we evaluate that difference. Now, if there was no difference, it was just due to random chance, what should you expect that difference to be? Zero. And it's not quite zero, but again, it's like, it's unsure, right? Maybe it is contagious, maybe it isn't, I can't tell. So we would like to really know how far this is away from zero. Is it statistically significant? So I didn't show you this, but so far you think you're not going to call your parents tonight and tell them about this bar graph that you saw today, right? So now how can we rigorously see how this contagion is due just to random chance? What do we do? Well, the first step is I need 50 cards. And I need 14 of these to be yawners and 36 to be not yawners. And I can't remember what color I'm going to have them, but let's make 14 of these red ones be my yawners. 2, 4, 6. Somebody else plays with it. Cards up. I'm going to ask you to do the following, actually. Can you record this as my phone up with me?
I got some. I can do it on my
No, I need it on my phone, because you guys don't have internet.
We do.
phone. We do.
Connect.
Sucks.
I have internet.
Yeah, what I'm doing. So I'm going to count. Pay attention, guys, because these are the kind of questions that you guys are always being asked, right? I'm going to take the red cards, and they're going to count for my yawners. So 2, 4, 6, 8, 10. Pay attention. 12, 14. Those are my yawners. They're going to represent the yawners. And then I'm going to count out the non-yawners, 36. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36. So these are my non-yawners right over here. And if this was due to random chance, I'm going to make a null distribution. If this was due to random chance, the next step is to take this entire group and put them together and shuffle them. Somebody can unshuffle them later, which is what happened here. But I'm just going to shuffle these cards. And I'm going to deal out my 1, 2 rows from this shuffled deck.
Wait, so why are you recording this?
Because you're going to be asked this question later, where it came from. Remember those questions you're asking, how does the null distribution, how can that be made? So where does it come from? And we forget, because we have lots of other stuff like that. So I'm going to shuffle these cards, and then
I can tell you again.
I'm going to take 34 of these guys. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 4, 6, 8, 32, 34. So these were the individuals that were shuttled with a Yancey. And they came from a card deck, so this wasn't real, right? So I'm making fake data. And we're going to let the red be the yawners and the blue be the non-yawners. So count for me how many red are in there. And count for me how many red are in here.
We don't need to count the blue.
No, just the red. Because the blue will come from that, right? How many red did you get?
6. I have 8.
All right, take boards and fill in the table.
Perfect. Are you gonna do a table right now?
Yeah, just you can erase that, what you have inside there, and just fill it back in. I put the totals on the outside.
You guys will.
You have to pay attention.
I was listening.
No, you can't listen to the top. When my lips move, your lips should.
Same thing.
prove it to you, JJ. If I ask you to redo this whole thing, explaining what I was doing right now, could you?
I could.
Exposed to
Show you?
not.
So finish this problem at hand, and then I ask you.
No, I don't want to explain it to everybody, you know.
Are we redoing this part too?
You can do the whole thing, yeah. Fill in that part.
Yes, they're supposed to be on TV. And then 6 did not.
You can get p-hat and the difference too. Yes.
And 30. I was like, oh.
All right, go ahead and take seats once you're done.
Subtract the young seed from the not young seed?
Yes, when you subtract the two.
Okay.
All right, so what you're getting is what we call one repetition. So this simulates a repetition that's, if it was random chance, if they weren't exposed to exposed to something, they're just coming in and they're going and randomly yawning, whether they're in one room or the other, it doesn't matter. The cards simulate that. That's how we're doing the simulation version. And that's one repetition of that. We filled that in already, but so in this distribution, the difference turned out to be 0.140 if you did your math right. You did it the other way, right? You made it, it's negative actually, but.
Oh, that's what, the negative sign's really low down.
Right.
I thought p-hat couldn't be negative.
It can. This is not p-hat, this is the difference between them. So that's a negative right now. You do have a small negative.
So what's that like?
So, huh?
What's
That's only one repetition. So if I did this thing with the cards 1,000 times, I would run out of room to record again. But if I did it 1,000 times, and I calculated the averages of those differences, what would you expect to see? Where would you expect that plum to be?
In the middle.
In the middle, right at what? Because this is random, right?
Right at 7.
0, right? Because that difference should be 0 in the average. Because there should be no difference with how you're assigning it. That proportion should be equal because you're randomly doing it with cards. They're not real, there's not a real intervention going on. Does that make sense? So that's what when they ask for one repetition, that's what they mean. That's why I recorded this. I'm going to put it on YouTube so you can see me actually doing it. Because you remember we talked about it with coin flips and stuff, but it still was kind of like, it didn't gel. So that's why I wanted a record of what we were doing. We can do this 1,000 times with a computer. I did not see this in any R code anywhere. So we can do it in R, but I'm going to talk to Major Adams and I'll ask along the way, what are we holding them accountable for in R? So if they want you to do this in R, I'll give you the code for how to do that and we'll practice it in class and make sure everyone knows how to do it. Right now, they wanted you to go to an applet online and look at what that looks like. It's exactly the little thing that you made in the air. Sam, you put that in there, there it is right there. It's the simulated 1,000 distribution. Has a spike right at 0, as you would expect, so the average is 0. And now I can ask, the one we found from the data that we had originally on the board with people going to the first 2 rooms, that difference was 0.136, which you don't remember, but it was back a few slides ago. We actually calculated the difference with the p-hats from the experiment run by the Mythbusters. So I can actually see it's this chunk right here that constitutes the p-value. This is what we shade in. And it turns out that that percentage or that amount is 0.2370. Is that evidence to reject the null?
It's not
It's It's not strong enough. This doesn't mean yawning is not contagious. This is something that I think confuses a lot of people. It just means that the evidence that I have from this study was not strong enough for me to say that yawning was contagious. And they give you the theory-based p-value. What's the difference between the theory-based p-value and the original p-value? The simulated one. What's the difference between the two?
The simulated one is going to be from your data group.
Right.
This one counts like all the 1,000 iterations.
So the simulated one, this one that's coming here, is just counting the amount of data that's in that yellow part. So it's coming from the simulated card data. The p-value is actually coming from an integral. This nice calculus-looking curve, it actually has a formula with exponentials in it. Remember the exponentials section of 104 that you love so much? That part of that class, there's an integral. Remember integration by parts? You actually have to do integration by parts, I think, to solve it. And you can actually integrate and find that area under the curve. So it uses calculus completely to find that p-value. You guys look really happy when I talked about exponentials and integrals, and integration by parts is really what excited people I saw. Okay, so you have now 20 minutes.